Okay, we'll get through as much as we can today. I'll put this in as a recording, calling it Review A, and then tomorrow's will be Review B, so you can watch both videos if you want to review the whole test. Okay? Identify the properties shown. This is the distributive property because they distributed 7 to get 7 times 11, and then 7 times 9. So distributive. Evaluate the expression. So this is where order of operations comes in. Okay, you have to do the order of operations first. So that means exponents first, because there's no parentheses. So I could rewrite this as 36 minus 25 times 2 plus 7. Multiplication next. So 36 minus 50 plus 7. And once I've got it down to plus or minus, I just go left to right. 36 minus 50 is negative 14, plus 7 is negative 7. Okay. Simplify the expression. So I'm going to distribute first to get rid of the parentheses. And remember to distribute the negative 2 to both. And now everything's plus or minus, so I'm just going to combine my like terms. I have negative 45 minus 6 is negative 51x. Negative 8 minus 7 is negative 1. That's it. There was no equation here, so you just had to simplify. Questions on that one? I skipped number 3. Okay, I'll go back and do that one. Question on 4, though? No? Sorry. 3. Evaluate. So I'm going to put negative 2 in for x and 5 in for y. 5 times negative 2, negative 2 plus 5. Is that divided by 5? So first I've got to simplify the parentheses. So it's 5 times 3 divided by 5. 15 divided by 5 is 3. Solve the equation. So I need to get x's on the left. So when I subtract 2.3 minus 1.2 is negative 2.2. And then divide by negative 2.2. Good? Okay, this is absolute value. With absolute value, you always have 2 answers. So you have to set up 2 equations. Drop the absolute value for the first one. And the second one is just equal to negative 5. There's always 2 answers with absolute value. So subtract, I get 2x equals negative 8. X equals negative 4. Or here I have 2x equals negative 18. X equals negative 9. I can always plug it back in and just make sure. 13 minus 8 is 5. Absolute value of 5 is 5. Or 13 minus 18 is negative 5. And the absolute value of negative 5 is 5. So both of those work. Solve the equation for y. Y equals negative 5x plus 7. Just have to subtract the 5x to both. The formula for the volume of a cylinder is volume equals pi r squared h. Solve the formula for h. That's the first part. So to get h by itself, I need to divide both sides by pi r squared. And then how tall is the cylinder with radius 3 centimeters, volume 200? So I just plug that in. 3 centimeters, 3 squared is 9. So h is going to be, and then I just plug that in the calculator, 200 divided by pi times 9. or 9 pi. Solve the inequality and graph it on a number line. So the first thing I'm going to do is subtract 6. 15 minus 6 is 9. And I've got to divide by negative 1. And when you divide by a negative, you flip the sign. And to graph that on a number line, it's going to be an open circle, less than. Questions there? Now I've got a compound inequality. Either 8x is less than 1 or x minus 9 is greater than negative 5. So to solve the first one, x would be less than 1/8. Or I'd add 9, x is greater than 4. So I have 1/8 and 4. It's less than 1/8 and greater than 4. Open circle because it's not or equal to. Okay, this one is an absolute value. So with an absolute value, you've got to set it up as two different inequalities. Yep. So the first one, you drop the absolute value. The second one, you drop the absolute value, flip your sign, make it negative. So x is greater than or equal to 1. Or here, x is less than or equal to negative 7. On a number line, if it's greater than or equal to, it's going to be solid. Less than or equal to, solid. Okay. Graph the relation and then tell whether or not it's a function. 2, 2, negative 3, negative 2, 4, 0, 0, 2, negative 3, 3, and 1, negative 1. So I can see right away it's not a function because a vertical line would go through 2 points there. So it is not a function. Evaluate the function for the given value of x. So all I have to do here is put 5 in for x. 80 minus 3 times 5 is 80 minus 15, which is 65. Next, graph the equation. Okay, it's in standard form, so the easiest way to graph when it's in standard form is just to find your intercepts. So when I cover up x, I know that the y-intercept is negative 5. When I cover up y, I know my x-intercept is 2. All I need is 2 points to graph a line. Something like that. Write an equation of the line with the given characteristics. So I'm given a slope and a point. So if I want to use the slope-intercept form, I can go ahead and plug the point in, the slope in, and solve for b.
It doesn't say solve.
It just says, well, I know, but I have to write the equation. In order to write the equation, I need to know what b is. So I have to solve for b. So I have 2 equals negative 2 plus b. So b is 4. So the equation of my line is y equals 1/3 x plus 4.
Wait. Yeah, that makes sense.
Next one, I'm given 2 points. So the first thing I have to do is find the slope. Negative 3 minus negative 7 is 4. 1 minus 5 is negative 4. So my slope is negative 1. And now I'm going to do the same thing I just did. I can pick either one of those points. So I'll pick this one. Negative 3 equals negative 1 times 1 plus b. I just plugged in 1, negative 3 in for x and y, and the slope was negative 1. Solve for b. Negative 3 equals negative 1 plus b. When I add 1 over, b is equal to negative 2. So the equation of my line is y equals negative 1x minus 2.
There you go.
Okay? Again, these first few chapters were just a review of Algebra 1, so you guys should have this down cold by now. Okay, write an equation of the line that passes through 1, 4 and is perpendicular to this line. Well, if it's perpendicular to this line, the slope of the line that's perpendicular to that one is positive 1/3. So I just write y equals 1/3 x plus b, and I plug this point in. 4 equals 1/3 x times 1, I guess. It's just 1/3 plus b. When I subtract 1/3 from 4, 4 is 12/3 minus 1/3 is 11/3. So that's what b is. It's an 11. Questions on that one? Okay, 18, I'm throwing out. That one is, we haven't learned yet. 19, draw a best fitting line for the scatter plot. Write an equation of your line. Well, to do a best fitting line, the first thing you do is kind of draw an oval around all of your points. And then I just connect the ends of my oval with as straight of a line as I can. Then I find 2 points that my line goes through. Doesn't have to be one of the points on the graph, but it can be. And I'm going to say I want to do it at an intersection, so I'm going to use this point, which is negative 1, 1, 2, 3. And I'm going to use the point here that it's actually on the graph. 1, 2, 1. Now that I've identified 2 points, I just write the equation of the line by finding the slope and solving for the y-intercept. Okay? So the slope is 1 minus 3, which is negative 2. 2 minus negative 1 is positive 3. So my slope is negative 2/3. Right? Then I just pick either point to plug in for x and y. And solve for b. Hello?
Do you have Malai?
Yes.
Could you send her? She's leaving.
Okay.
Thank you.
Malai, you're leaving.
I'm leaving?
Okay, 3/3 plus 4/3 is 7/3. So my equation then is negative 2/3 x plus 7/3. And this is the kind of problem that everyone might have a different answer, but as long as your work shows the process, because your oval may be different than mine and your line may not be maybe straighter than mine and it went through different points. That's fine, as long as you picked 2 points on your line and then you found your equation. It'll be approximately the same for everybody. Questions on that process?
As long as we don't get like 4,000 something.
Yeah, as long as it is close. I mean, if you tell me the y-intercept of your line, how did I get a positive y-intercept? I mean, that's what I would do, is question that equation. Because my line goes through a negative y, doesn't it? But I got a positive y-intercept. So something is not right. So what I would do is look at this one. This is negative 1, negative 3. Not negative 1, positive 3. Right? So it's a good place to check your work and see if your y-intercept makes sense. Mine didn't. So this would be 1 minus negative 3, which is 4. And 2 minus negative 1 is 3. So this is positive 4/3, which makes that positive 8/3. 3/3 minus 8/3 is negative 5/3.
There you go.
Now I say, that makes more sense with my graph. Okay? All right, graph this function. It's an absolute value, so what should my graph look like when I'm done? Should be a V. And it's got a negative in front of it, which tells me it's going to be opening down. And I can figure out where it starts. It's positive 2, positive 2. Right? If it says x minus 2, that means the x value is positive 2 and 2. And I'm using a slope of negative 1/3. So I'm going to go down 1 over 3, down 1 over 3, and then just mirror that on the other side. And it's a really wide V. Questions on how to graph those? They're really pretty easy once you remember the general form. If it's a negative, that means the x value is positive. Yeah?
Don't you have to shade?
No, it's not an inequality, it's an equation. You only shade inequalities.
Connection will be
Okay. Next one is an inequality, and it's a line. So first thing I do is graph the line. Negative 1 is the y-intercept, and the slope is 3. So I go up 3 over 1. Nope. Yes, up 3 over 1. That's right. Connect them with a dashed line because it's not an or equal to. And then shade. And I'm going to use 0, 0 because it doesn't go through 0, 0. Is 0 greater than negative 1?
Yes.
Yes. So this point is included in the shading. And there's my shading. Drop my pen.
Doing magic trick.
Yeah.
I honestly didn't even see her graph it.
All right. Graph the linear system. Oh, let's use blue. So all I'm going to do is graph both equations. Plus 4, and the slope is negative 1 over 3. And then the line y equals 6. So this graph, this system has one solution. And it looks like it's 1, 2, 3, 4, 6. What I can do is just check it. If I put 4, 6 in here, is 6 equal to negative 1/3 times 4 plus 6 plus 4? Huh. Is that true? Is it? So negative 4/3 plus 4. Is that 6? So this should have been, well, it should have been a negative 4 anyway, but it wouldn't matter because this is positive 4/3 plus 4, right? So this goes up 1 over 3, so that point's really there. Up 1 over 3. So it must be this point here, right? 2, 3, 4, 5, 6. Negative 6, 6. Let's try that. 6 equals negative 1/3 times negative 6 plus 4. Negative 6 divided by 3, negative 3 is positive 2 plus 4 is 6. So this is my solution. It says if there's exactly one solution, estimate it, and then check it algebraically, which is what I just did. So you can see the problem you run into if your graph's not perfect, if you don't use a ruler, right? And so you always need to check it. Just because it looks like that's my graph looked approximately negative 4, 6, when I checked it, it wasn't true. So I had to go back in and kind of look at my graph again. Okay. All right. This one says solve the system using any algebraic method. Well, I'll probably use elimination here. And I'll just multiply this by negative 3. get rid of my y's. If I do x, even though there's a positive and negative, I'm going to have to multiply both equations by a number. It's easier just to do one. So this gives me 8x plus 3y equals negative 2, and 15x minus 3y equals negative 3. So this is 23x equals 5.
Negative 5.
Yep. Negative 5.
Wait, no, it's actually 1.
When I
Because negative
add these?
times
Oh yeah, this is 9.
that's 9.
Oof.
7.
Good catch. So this is 7 over 23. Do that right? Negative 3 times negative 5 is positive 15. Okay, so 7/23, and then how do I find what y is? Plug that back into one of these. I'm just going to plug it in here. Negative 5x plus 7/23 equals negative 3. So I could multiply everything by 23.
Wait a minute. Mrs. Reader, wouldn't you put x in for x, not for y?
Yes, I would. It's just already shaping up to be one of those days. Okay,
There you go.
that's better.
Now 5 times
I'm going to get a
7 is
calculator.
35.
Yeah, so 35 over 23.
That's not even.
Nope. Negative 35. Plus y minus equals negative 3. So I'm going to multiply everything by 23 to get negative 35
69. Plus.
plus 35 or 23y equals negative 69. Add 35 and I get 23y equals negative 34. So y is equal to negative 34 over 23. Next one, 3 equations, 3 unknowns. So if I use elimination here, I'll add the first 2 together. Did I do that one right? Then I'm going to multiply this one by 3, because I need to eliminate another y. And then I get 3x minus 3y plus 3z equals 0. So when I add this with this, I get 6x, 0, plus 9z equals 4. Right? Now I've got 2 equations, 2 unknowns, so I'm going to go ahead and just multiply this one by negative 3. I get 0 equals 1.
That's not possible.
What does that tell me?
No solution.
Why? What does that tell me about the 2 lines?
That they are perpendicular.
Nope. Parallel. Parallel. Yep. So no solution here. Okay. Next, graph the system of inequalities. So I just graph the lines and then shade, and wherever the shading overlaps is where my solution is. So the first one, I'm going to use y-intercepts and x-intercepts on these. When I cover up x, y is negative 3. When I cover up y, x is negative 6. So when I put these together with a solid line, because it's an or equal to, looks like that. Next one, cover up x, y is 1. Cover up y, x is 2. Do they have the same slope, these two? They do. So they are parallel. That's kind of what it looked like. And then I have y is negative 1.
So it's just a
Yep. Okay, now I'm going to shade everything. So when I put 0, 0 in for the first one, is 0 greater than -6? Yes. And that was this one, so it's going to be shaded above the line. Then when I put 0 in for the next, is 0 less than 2? Yes. So it's going to be between those two. And then, I don't know what to use. We'll use red. All right, and then the last is 0 greater than -1. Yes. So it's going to be this boundary right here. Going on forever will be my overlap. Okay. Next question. Find the area of the triangle. Well, this formula is plus or minus 1/2 times the determinant. -1, 0, -3, 3, 0, 4, 1, 1, 1.
Yay.
Calculator.
I like this one.
I just go second matrix, go to edit. Needs to be a 3 by 3. I enter in all of these numbers. -3, 3, 1, and 0, 4, 1. Then I go back to second matrix, go to math, down to determinant. Matrix, math, determinant, and then I pull in that first matrix that I had and hit enter. I get -11. It's not what you got, is it, Sam? And then I'm going to check my matrix real quick. -1, 0, 1. -3, 3, 1. And 0, 4, 1. -11. So when I take plus or minus 1/2 of that, the plus or minus just means the area can't be negative. So really it's the same as the absolute value. So if I take this divided by 2, I get -11/2, but it's really positive. All right, solve the equation by factoring. So I can't factor anything out, so I'm going to take 4 times 15.
Bottoms up.
Yep. X. One's positive, one's negative. 30 and 2. And 30 has to be positive. Then I have to divide by 4. Simplify. And then bottoms up. 2x. Well, it says solve by factoring, so I really don't have to do bottoms up if I'm solving, because x is going to be -15/2 or positive 1/2. I could go ahead and bring it up, but then eventually I'm going to have to divide by it anyway, so it just saves a step. If it just said factor, I'd want to bring it up. But solving, I'm okay. All right. Simplify these two radicals. First one is the square root of 500, so I'm just going to take 500 and what is that, 105? 20 and 5?
15 and 4 and 5.
Okay, so I can see right now this is a perfect square. So that's 25. So it's the square root of 25 times the square root of 4 times the square root of 5. Or this was a perfect square, right? Square root of 100 times the square root of 5. Get the same thing. What is that? 5 times 2? 10 square roots of 5. Or the square root of 100, 10 square roots of 5. Okay. Now the square root of 8 divided by the square root of 3, I have to rationalize the denominator. So I could break this apart like this. And I get the square root of 24 over 3. But the square root of 24 has a perfect square in it, 4. So 4 and 6. So 2 square roots of 6 over 3. All right, solve the quadratic equation using any appropriate method. Tell you right now, what you know so far, you can't do that one. So 31's thrown out too. Minus 13?
3.
I know, but I was 14. I was bringing over. I guess I could do it that way too. Let's just do this. X squared equals 2. X equals plus or minus square root of 2. If you don't put the plus or minus, it's minus a quarter point.
Oh my. That's gonna suck.
We'll just put it.
Plus or minus.
Next one, x squared plus 4 equals negative 32. So x squared equals negative 36. So x equals plus or minus 6i. Square root of a negative, you always have an I at the end. Write the expression as a complex number in standard form. Negative 4 minus 7 is negative 11. 2i plus 3i is 5i. Solve the matrix equation for x and y. Well, I have what? 2, 10, 6, negative 4, minus negative 2, 1, 1, negative 3, equals x, 9, 5, and y. So I'm interested in the top left, the bottom right. The top left is going to be 2 plus 2, so x is 4. And the bottom right is negative 4 plus 3, negative 1. Negative 4 plus 3 is negative 1. Right? Negative times a negative is a positive.
10 times 10 minus 1.
Yeah, is 9. And 6 minus 1 is 5. But I just needed to solve for x and y.
Look at you go.
Okay, so if I have two matrices, and I'm multiplying, I could first check and see if these are even if I can even multiply them. This is a 2 by 3. This is a 3 by 2. As long as the insides match up, it works. And what kind of matrix am I going to have when I'm done? A 2 by 2. So I can go ahead and draw that one in. I'm going to have 4 numbers I need. So I take 0 times 1 is 0. 2 times 0 is 0. Negative 6 times negative 7 is positive 42. 0 times negative 6 is 0. 2 times negative 9 is negative 18. Negative 6 times 8 is negative 48. So that's what, 66? Negative? 9 times 1 is 9. 0, 0. 9 times negative 6 is negative 54. Plus 9. And then 0. Negative 54 plus 9. And there's my matrix.
Look at that.
Oh, nice. Yeah. Kramer's rule. Kramer's rule The denominator is the coefficient matrix, the determinant. And the numerator for x, I just take the constants and I plug them in for x. And for y, plug them in the y column. Right? With a 2 by 2, it's pretty easy. You multiply these together, you get 3. Multiply these together, minus 6. So the denominator for x is negative 3. And for y is negative 3. Then I have 12 minus 33.
21.
Negative, right? And here I have 33 minus 24. Is that right?
Yeah.
33
No.
minus 24,
9.
9. And it's positive. So x is 7, y is negative 3.
Wouldn't you switch the... Okay, so 3 times 1, but wouldn't you switch the opposite?
It's 3 times 1, which is 3, and then you subtract the opposite.
But which is...
Tell me when you're doing the
Oh, never mind. Wrong one.
What kind?
All right. Use Kramer's rule for this one. 1, 1, 1, 2, negative 1, 3, 3, 2, negative 1. That's the denominator. For x, my numerator is negative 4, 1, 4, 1, negative 1, 2, 1, 3, negative 1. Okay, with these, just get your calculator out. And then just do second matrix. I'm going to go ahead and figure out what the denominator is. So 1, 1, 1, 2, negative 1, 3, 3, 2, negative 1. And then I'm going to go determinant of A. Maybe. Determinant of A. 13. So my denominator is 13. To find x, I've got to go back and plug those numbers in. Negative 4, 1, 1, 1, negative 1, 3, 4, 2, negative 1. And then determinant of that is 39. 39 over 13 is 3. Then to do y and z, just do the exact same thing, except you're going to plug negative 4, 1, and 4 in for y to find y, and negative 4, 1, and 4 into z to find z. Okay? We'll pick up on number 37 tomorrow.